do you suspect that they're doing anything innovative, or are these just sort of incremental improvements because people are getting better and better at training and refining and prompt engineering, RAG, all that? Is it just one big thing, or have they done something crazy here that is
No, if you look at the actual research paper space, there's been well, one, there's a lot more papers today, and two, there's been a steady progression of these things. And so to the public, it looks like, oh, all of a sudden it's much better. It's like, no, it's been improving days and weeks and months for the last 12 months, but you're just seeing the results after 12 months. You're not seeing the results of all these little improvements.
Welcome to Practical AI, everybody. My name is Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights in your model while increasing accuracy. Peter, wanted to talk a little bit about OpenAI again. They came out with a release, a look into the future, and they're talking about O3 and O4.
Yeah.
Tell us a little bit about what the press release was and what the demos kind of demonstrated.
Yeah, so they're basically responding to DeepSeek and Manus. They're trying to give people previews of what's coming because now that the competition has heat is picking up, they can't just sit on stuff and wait 6 months or 12 months, right? So basically, O3 is supposed to be better, and O4 actually isn't as good as O3, but it will eventually be better than O3.
Okay, and we'll include one of the videos that kind of helps talk about the benchmarks and how it's doing, or how these new models are doing. But some stuff sort of comes up there. We talk about tools. They talk a little bit about agentic AI, and from more of a novice perspective, it's getting blurry now a little bit. Like, what
Yeah.
exactly is agentic AI, and what's like a regular LLM? Explain the difference there, and how OpenAI is thinking about these and where they're going with LLMs and agentic AI.
Yeah, so I think that the first disclaimer is that their definition of agentic might not be what other people are defining it, and they haven't really clearly defined what they consider agentic. So this is just my interpretation. But basically, agents is an idea of you have different AI that then work together. So the idea is you have multiple AIs working together to do something. So it's just kind of like the mixture of experts idea, right? So that's mixture of experts actually another format of agents. Right. So you got multiple models and they're doing things together. So in the case of O3 and O4, they had this comparison between no tools and with tools. And the big takeaway was with tools, it does better. Meaning that so no tools is just the LLM, just like ChatGPT. With tools means it can do things like query the internet, search the internet. It can actually write code, deploy it onto a Linux system, try to compile it, try to run it, start the web server, use Chromium to look at the page, validate the page is good, right? So it can do a whole bunch of other things, which then gives it more feedback into like, oh, this is the correct response to this prompt.
Okay, so there's a commonality between tooling and agentic AI. So basically, an LLM is just something that can kind of say something, or reveal something that's been written, whereas agentic AI can actually do something. It can build something, but it needs access to your operating system, to the cloud servers, or to whatever in order to pull that off.
Yep.
So that sounds pretty risky, right? Sounds like, that's there's like a bad rabbit hole you could go down. Um, let's switch over quickly just for context purposes. Let's switch over to Manus. What does Manus have access to? What tools does it have in order to pull off what it did in its demos?
So Manus, so they had their first kind of general purpose agent thing where you could tell it build me a website. It would actually think about it using, so they used a combination of Claude, their own agents, other LLMs, that then it would, so if you say, go me a website for, let's say, trading Pokemon cards. It would search the internet for Pokemon characters, Pokemon cards. It would generate the web page. It would generate a database. It would write the code to connect the website to the database, and then it could then deploy it to a cloud service and then start the web server and then show you the results.
So the tools involved were, you know, access to files, access to data, access to a database, access to a website. What, like, did they have like their own partitioned version of all this ready to go in some, some partition of AWS? Or did it have the freedom or the ability to just go pick one? Like, I'm going to go fire up, I'm going to go start a GoDaddy account and I'm going to register a domain name. Like what was it do? Like, what were these tools actually doing?
So everyone is taking the same approach. They would create a container. So this is like Linux terminology. Container is just like a package of software, but it's contained in an environment. So you can control the security. So a couple things about that is you can control the data coming into the container, data coming out of the container, the connections into the container and coming out of the container. So you can really tightly control that container. And then so they run their thing in that container so that it's controlled. And if ever wanted to kill it, you just kill the container.
Okay. Got it. So the way to protect your own laptop, for example, is just to containerize everything and make sure it's not getting access to all of the
Exactly.
operating system and all of your personal data and everything. Okay. All right. So back to '03 and '04, the benchmarks were really strong on these. It seems like they're making some big advances. Do you suspect that they're doing anything innovative, or are they, are these just sort of incremental improvements because people are getting better and better at training and refining and using models with other models and other technologies and just prompt engineering, RAG, all that? Is it just one big thing, or have they done something crazy here that is
No, if you look at the actual research paper space, there's been well, one, there's a lot more papers today. And two, there's been a steady progression of these things. And so to the public, it looks like, oh, all of a sudden it's much better. It's like, no, it's been improving days and weeks and months for the last 12 months, but you're just seeing the results after 12 months. You're not seeing the results of all these little improvements. So it's been a continuous refinement and improvement, but people are like, well, this is all new. It's like, well, no, like it's been, if you follow the papers, you know this has been happening.
yeah. One of the things that that the demonstration did was show that the code produced by their the '03 or '04 agent was in the top 200 of all programmers in the world, or something like that. Something.
Right. Yeah. The metric was that based on like co-competition results that it
Okay.
ranked top 200. But to be honest, if you look at like leak code, for example, the top 10, or the top 10 because one, it satisfies the criteria. Like a competition on leak code might be write a sort that is like this fast on 10 million records. Is it great code? Probably not. Was it fast? Yeah, it was fast. Is it readable? Is it well documented? Is it componentized, modularized? No, probably not. The person just wrote it to be as fast as possible to win the league code competition. So when people see like these benchmarks, like it scored in the top blah, you need to like, realize, okay, this is a very specific test to measure a specific thing, and it's not generally applicable to like real software you want to write and maintain.
Okay. Last question then. Let's go all the way up to kind of something we talked about last week, and that is Social Security system. So in the examples that on the '03 and '04 models, they gave it like an image, a chart with a bunch of information on it. It read the chart, it found the answer in one of the pictures, and And it was a pretty cool, demonstration of these things, multimodal and getting highly accurate, right, on problem solving. Um, how far away do you suspect we are to being able to show a one of these models, one of these solutions, one of these agents, essentially an entire system, right? Like the Social Security system,
Hmm.
have it deconstruct everything into requirements and then build the system again um, in a way that reasonably could be tested and implemented.
So it's a valid question. It's a great question. The short answer is we're still far away from that because one thing is if you look at the training data they're using to train COBOL, it's maybe at best it's 10% of the actual COBOL code out in the world, right? Like every bank, the Fed, pretty much every country that's modern uses COBOL on a mainframe to process the taxes, the data, like just like everything.
Yeah,
Every one of our transactions in the US goes through some COBOL system at some point.
right.
And I think like if you ask how many lines of COBOL exist in the world today in the US, it's probably over 100 million lines of code. It's probably 10 times that. Like no one really knows. This is one of those things where like just in the social administration, their code base is like probably over 100 million lines of code.
Yeah.
So the thing is that code was not used to train OpenAI, right? So could you do it? Yes. But you would need to then extract out all the COBOL code from all the different places and then train it for 12 months and then rinse and repeat for a few years until it got really, really good at real COBOL that real humans wrote.
So you're saying that the agentic solution would be that the agent is reading the code, the COBOL code. What about just watching the app work at all the different layers and then deconstructing down the requirements and rebuilding some app that works better or similar, but with a different code base?
So yeah, in theory, you could install a network sniffer, look at the communication between two systems. So let's say you have your callable business logic and then you have your database. So all that's going to tell you is what data it's reading, what data it's writing. It doesn't tell you how to derive any calculations,
Mm,
right? So to do that, you need to peer into that system that is doing that calculation, that business logic. And it might be convoluted. It might be like stuff written 60 years ago that was modified 80 times, and each person that modified it didn't document it. And so it's this spaghetti code of like it was written 60 years ago, modified 80 times, and like no
got it.
one today live would know like what the heck's going on.
So anytime you're doing something with business logic, like, as simple as like maybe having a factor for a currency exchange or something, or store procedures or something like that, you're basically getting into a zone where it's sort of masked. It's unknown what's actually happening inside there.
Well, I mean, it's even more complicated than that, right? Like when they built these systems early on, like a common thing is like the primary key.
Mm,
So early on, people use integers for primary keys, but integers have a certain range. Once your value is above the highest range, well, some people do the opposite. They go, well, let's just flip the numbers to negative. And I've seen this in systems where I'm like, why is the primary key positive for these records and negative for these other ones? It's like, well, we ran out of space. And I'm
yeah,
like,
yeah,
so why don't you like change it to a UI, a GUID ID or some other form of ID that's not an integer? And they're like, well, we had like 50 billion rows and we didn't have time, the
yeah,
manpower, the systems to do it. So we just said, well, just flip the numbers to negative for the primary keys. And you're like,
yeah.
but at some point, you're going to run the whole entire range of the positive and negative. And they're like, yeah, we know that, but
Someone else's problem.
that's what else problem. Exactly. It's like, that's not my problem. I
Yeah.
just need to get a run for this month.
Or what we heard for years, it'll be replaced by then. It'll be irrelevant.
Exactly, but it never
It
does.
never does. All right. No,
Right.
this is good. Good stuff. All right. Well, we'll keep an eye on we'll keep an eye on what OpenAI is doing when they finally release these new and improved ones with these high benchmarks. And I'm assuming that, next up is something like Anthropic or Meta,
Yeah.
or someone's going to drop another thing, and we're just going to keep going down this path of sort of linear improvements. So, Peter,
Yeah.
thanks. This is good stuff. Be sure to follow us on Spotify. We are there. You can catch the audio version. And if you didn't pick this up already, always listen to us on 2x speed because Peter and I talk slowly. We will catch you again next time. Thanks, everybody.